Good morning everyone. My name is Teja. My registration number is 21BQ1805J7 and I am from CSE section. Today I was here to discuss about the topic of hysteresis. In this we see that what is hysteresis and the hysteresis in ferromagnetic material. Let's see what is hysteresis. Hysteresis is defined as the loop or curve plotted on BH coordinates, which shows how the magnetization of the ferromagnetic material is varies when the material is subjected to periodical reversal magnetization. That means when we are increasing and decreasing the positive and negative magnetic field on the material. That was seen in the process step by step. Let's see about it. At first, initially the substance is at zero, as that there was no external magnetic field on the material. And when the material is placed in an external magnetic field and increasing the external applied magnetic field, the material magnetizes rapidly and reaches a point called saturation point. Here the material did not get magnetized again and it is stay at constant. To bring the material to zero, we remove the applied external magnetic field and make it to zero, but the material reaches to a point on B axis, as B is the magnetic flux density and the point is represented as Br. Here Br means residual magnetism or retentively. Here at present the substance is here. The word retentively means the amount of magnetic flux remains in the material when we remove the external magnetic field. And now to reduce the residual magnetism to zero, we apply a negative magnetic field on the material, and after that it magnetizes and reaches a point, and the point is represented as minus Hc, as it is the H coordinate, which means external magnetic field, and it is a negative coordinate, so we keep minus Hc. Here minus Hc is called as corrosive field or corrosively. Here the word corrosively means amount of magnetic intensity required to destroy the residual magnetism to zero, as we are using this negative magnetic field to make the residual magnetism to zero, and further we increase the negative magnetic field again. It reaches a saturation point, and that saturation point is called as saturation in opposite direction. As it is the normal direction and it is in the opposite direction of this, or this point is also called as negative saturation. And when we remove the negative magnetic field to zero, it does not travel in this path and creates a new path and travel and reaches a point on B coordinate, and this point is called as minus Br, as it is on B axis and it is of the negative coordinate of the axis, and it is minus Br is called as negative retentively. Or negative residual magnetism. And again, to destroy or make the negative residual magnetism to zero, we apply a positive magnetic field on the material, and by this positive magnetic field applied on the material, it reaches a point in the h-axis, and this point is represented as Hc, as it is the positive axis. And here Hc is also called same as the coercive field or coercively, as we all know that the definition of coercivity and coercively. And when we further increase the positive magnetic field in the material, it magnetizes and reaches a starting point as saturation point. And here this complete a cycle or a loop. This cycle or a loop is called as hysteresis loss curve or hysteresis loop. And from this graph we see that these 2 points Br and minus Br, as the applied magnetic field both positive and negative are zero, but the magnetization of the material is not zero. So we find that at these 2 points the material can act as a permanent magnet. So thus we find that the magnetic flux density B is always lag behind the magnetic field intensity H. This lagging of B behind H creates the hysteresis, and we see that this process is a reversible property, as this material has a reversible property. That means when we remove the external magnetic field, but the magnetization of the material is not zero, and this contains some energy, and this energy is converted or lost in the form of heat in the material, and the material is not going in the initial path. So it is called that the material has reversible property. And I was representing the names of this material, this curve, as this is the initial point as A, and it is B, C, D, E, F, and we find that the curve or loop A, B, C, D, E, F creates a loop, and the area enclosed between this A, B, C, D, E, F is called as hysteresis loss. And when we repeat this process of increasing and decreasing the magnetic field in the material, this again creates the same loop. I think as you are understand and now familiar with the topic of hysteresis in ferromagnetic material, hope you understand this. Thank you. I'm sorry that this is the loop that A, B, C, D, E, F, and again A, which creates the closed path or closed loop. Hope you understand that. Thank you.